I shipped a code review agent in January. It worked perfectly in testing. In production, it broke within 4 hours and nobody noticed for 3 days. The agent extracted structured findings from LLM responses, file path, line number, severity, description. It filed them as tickets. Simple enough. In testing, every finding came back with a clean integer line number. In production, the model returned the string around 42 for the line field instead of an integer. Pydantic threw a validation error. The batch failed silently. The agent kept appearing to run. It just stopped producing output. This video is about the fix and why prompting your way out of this problem does not work. The first thing every developer tries is a better prompt. You add a line to the system prompt, always respond in valid JSON, or your response must conform exactly to this schema, and it works in tests because tests use clean inputs. Production is different. There are 5 specific ways a model can return JSON-shaped output that breaks your parser. First, prefix text. The model writes here are the findings, and then starts the JSON object. Your JSON parser sees a string that does not begin with a curly brace and throws. Second, trailing commas. The model follows JavaScript conventions and adds a comma after the last field in an object or array. Valid in JavaScript. Invalid in JSON. Third, null instead of empty array. A schema that expects an empty list when there are no findings gets null. Same semantic intent, different type, fails validation. Fourth, inline comments. The model adds a JavaScript-style comment inside the JSON body, 2 forward slashes followed by a note, not valid JSON. Fifth, markdown code fences. The model wraps the JSON in triple backticks with the JSON language specifier. Correct format for a markdown document, not correct for a raw API response your code is trying to parse. None of these are hallucinations. They are all statistically plausible given the model's training distribution. Adding stronger prompt instructions shifts the probabilities, it does not eliminate them. You cannot prompt your way to a guarantee. Constrained generation works by inserting a step between the model's probability computation and the sampling decision. Normally, the model generates tokens one at a time. At each step, it computes a probability distribution over its entire vocabulary, often 50,000 or more tokens. Then it samples one token from that distribution. Constrained generation adds a mask at the sampling step. The mask is a vector the same size as the vocabulary. Every token that is valid at the current position in the output schema gets a 1. Every token that is not valid gets a 0. The probability distribution is multiplied by the mask before sampling. Tokens with a 0 weight cannot be sampled, regardless of how high their raw probability is. The mask is computed by a finite state machine. The FSM tracks where you are in the output grammar, in this case, a JSON schema based on every token that has been produced so far. If the schema says a field is an integer, and the FSM has tracked that you are now producing that field's value, the valid token mask allows only digits, a minus sign, and the structural tokens that end in integer. The string around, the word null, a quotation mark, none of those are in the valid set. 2 properties make this practical at production scale. First, the FSM is compiled once per schema and cached. You pay the compilation cost at startup, not at inference time. Second, the per token mask lookup is constant time. The overhead per full generation is typically under 5 milliseconds, regardless of response length. On the Anthropic API, the constrained generation interface is tool use. You define a tool, in our case, extract findings, with a JSON schema as the input schema. The schema specifies each field's type and constraints. File as a string, line as an integer, severity as an enum with 4 values, description as a string with a max length. You set tool choice to the object with type any. This tells the model it must invoke at least one tool. The API applies the FSM-based constraint automatically, no additional setup required. When the response comes back, you access block.input on each content block. That is already a Python dictionary matching your schema. You do not call JSON.loads. You do not instantiate a pydantic validator. You do not write a try-except block around a parsing step. The shape guarantee was applied at the token level before the response was even transmitted. The silent failure from the cold open cannot happen in this setup. The token around is not in the valid token set when the FSM requires an integer literal. The model literally cannot generate it. If you need exactly one tool invocation per request, common for single item extraction, set tool choice to type tool with the specific tool name. That constrains the model to invoke that exact tool once. One reliable signal that you have moved the constraint to the right layer. The validation error handling code disappears from your codebase. The try-except around JSON.loads, the pydantic validator call, the retry loop for parse failures, you delete all of it. When you find yourself deleting defensive code, that is confirmation the problem has been solved structurally rather than patched. If you are running local models, Llama, Mistral, Phi-4, or any other self-hosted model, the Anthropic tool use interface is not available. But the same FSM-based guarantee is through the Outlines library. Outlines integrates with the Hugging Face Transformers stack. The usage is minimal. You load your model normally. You call outlines.generate.json with 2 arguments, your loaded model and a pydantic class that defines your schema. Outlines compiles the FSM for that schema. Then you call the return generator with your prompt, and you get back a typed pydantic instance, not a string, not a dictionary, a pydantic instance. There is no parsing step. The compile once behavior is the same as the API path. You compile the FSM at startup and reuse it across all requests. For schemas with 20 or fewer fields, Outlines benchmarks show throughput within 2% of unconstrained generation. The per-token mask computation is fast enough that it does not materially impact throughput at production scale. The structural guarantee is identical. If your pydantic class says a field is an integer, the FSM will not allow the model to produce anything but an integer at that position. The constraint is enforced in the logits processor, below the application layer, before any of your code runs. For systems that need to route between cloud and local models depending on the task, the downstream code is consistent. In both cases, you receive a schema-valid object. In both cases, there is no parsing step. The tool use wrapper and the Outlines wrapper both enforce the same guarantee through different mechanisms. Constraint generation solves the structural problem. 3 failure modes survive. First, semantic invalidity. Constraint generation guarantees shape. It does not guarantee meaning. If your schema has a severity enum with 4 values, the model will always produce one of those 4 values. It will never produce an invalid string. But it can produce info when the finding should be critical. The shape is valid. The meaning is wrong. Your evaluation layer, your human review process, your downstream quality checks, those are still necessary. Second, truncation. If the model hits your max tokens limit while producing a JSON object, the output is truncated mid-structure. The FSM tracks valid tokens given what has been produced, but it does not know about your token limit. The fix: set max tokens to your estimated output size times 1.5. For structured extraction, the output size is predictable from your schema. Calculate it and set an explicit upper bound. Never leave it at the API default. Third, schema and prompt mismatch. If your schema requires fields that your prompt never established context for, the model will populate those fields with low-confidence guesses. Constraint generation enforces the schema but does not ensure the prompt prepared the model to populate it meaningfully. That alignment is your responsibility, and it requires maintenance as both the prompt and schema evolve. The production pattern from 6 weeks and 22,000 calls is 5 practices. Tool use with tool choice any on every structured call. Strict types and enums for all categorical fields. Max length on string fields. Max tokens bounded at estimated size times 1.5. Structured escalation when tool call count is 0. 0 schema validation failures. The bugs that remain are semantic, and those are the interesting ones. Full code in the description. Blog 268. podcast P047, shorts S160 and S161. Like and subscribe.